In the previous lecture, we proved such properties for remembrance. We can write that like zero vector, a zero vector equals to zero vector. Second one is alpha into zero vector equals to zero vectors. Third one is said that a of minus alpha equals to minus of a alpha. Fourth one is take that is minus of a alpha equals to minus of a alpha. Now today we are proving the fifth properties. The property which is said that is a of alpha minus beta equals to alpha minus a of beta. By using the above previous proof, we get this conclusion. Taking this left hand side part minus beta. Can we write like that? This a of alpha plus minus of beta. There is nothing. Okay, change. A of alpha plus a of minus beta by properties of vector space. Okay, again, if this a alpha plus a of minus beta, by using this property number third there, this minus is coming from the outside of that, it's come like that. A of alpha is minus of a of beta. That's how we got this our proof minus beta. Now we're going from the next one, which is sixth one, and we are proving the fifth one is said that this a of alpha minus beta, we got a alpha minus a of beta. The next property, sixth one, it said that this a alpha equals to 0, which means if a equals to 0 or alpha equals to 0 vector, sorry, there's 0 vector anyway. The sixth property say that this a alpha equals to 0 vector, which means if a equals to sorry, I'm just on this problem. A equals to 0 vector or alpha equals to 0 vector. That's all. Now taking there we use two conditions. First we prove like this, if this then that, and we prove the opposite of that also. Proof start from there. Okay, let we suppose a is not equals to 0 vector, which means suppose then a inverse belongs to field. Okay, if that is happen, this happen, so we take this a is not equals to 0, which means a alpha equals to 0 vector. Step forward, next one, we know we have a inverse also, multiplying a inverse both sides, a alpha to minus a inverse both sides into 0 vector into a inverse. By the above property, this also goes 0. No, 0 vector, 0 vector. It is given part multiplying both side a of inverse. Next one, okay, here's this a inverse into a, and there is alpha, and that is called a 0 vector. Again this become a 0 vector, this become a 1 because the identity element, and this 0 vector into a inverse also give us 0 vectors. So 1 1 alpha equals to 0 vector A into A inverse 1, and when we deal with this we get alpha equals to 0. We prove that this is not equals to 0, then the alpha equals to 0. Now we are proving just opposite of that. If alpha is not equals to 0, then a equals to 0. Opposite of that, we prove that we try to prove that if alpha does not equals to 0, then a equals to 0. And this part is we are proving by the taking the contradiction. Contradiction simply taking if we assuming the wrong thing, or the assuming the wrong something, and we if we assuming the wrong thing, and we then by the processing on the other process of this mathematical, our result is also coming around. So same as that. If we suppose that uh, a is not equals to 0, same. If a is not equals to 0, there's a inverse exists in f, then a inverse exists in that. And a of alpha equals to 0 vector. Sorry, that's because these are vectors. I miss it. 0 vectors, and by multiplying both sides with a inverse, we got it. That's a of a inverse alpha equals to 0 vectors a alpha multiply inverse both sides. Okay, so viscous alpha equals to 0, and which is a contradiction, which is a contradiction, because this contradiction is that we prove that this a is alpha is not equals to 0 vector. This a equals to 0 vector. If we assume that the a is not equals to 0 vector, then we get a wrong result. If we assuming wrong, we are getting a resulting wrong. So which is proof that this, if a equals to 0 vector or alpha equals to 0, said like that. The seventh one, if a alpha equals to a beta, then there is alpha equals to beta. And as we know, for all alpha and beta belongs to V, and this a belongs to F. Field couple. Field a alpha equals to a beta, then alpha equals to beta. That's all. Proof. For proving this, we use the above proofs of that. We have a alpha equals to a of beta. By step forwarding, we are shifted it a of alpha minus a of beta. So 0 vector, shifted it. Now we take a as a common, and alpha minus beta equals 0 vector. By taking the above properties, property number 6, if this is a equals to 0 or this a minus b equals to 0, now this a minus alpha minus beta equals to 0 by property by property number 6. Okay, now it comes this alpha equals to beta. Eighth one, it is like same that we just said this. If a of alpha plus b of beta, which means a of alpha and b of alpha is known as a cos to b. Eighth property is saying like that. A alpha equals to b alpha, which goes to a cos to b equals to b. Proof. Now we take this part. A alpha equals to beta and b alpha. Step forward. We shift it there, or we can a alpha minus b alpha equals to 0 vector. The step in subtract b alpha both side. Okay, again we take common at alpha, take common, then inside a minus b 0 vector. By vector property, well, the above theorem terminals at proof number 6, we tell that if this one is 0 or this one is 0, this a of minus b equals 0. Where property number 6th, and the final is a equals to b, comes to calculation. That is the part of this proof. We takes this one is a0. Okay, so what we did for proving that it is a 0, we put there's 0 as 0 plus 0. Here we use 0 as 0 plus 0, and while proving of this a 0 plus 0, this taking the right hand side and right hand side this, and we prove this, take it as 0 vector equals to 0 vector plus 0 vector. Proceeding in both of those of first to second, we use same thing. 0 equals to 0 vector equals to 0 vector plus 0 vector in both of them. In this case, we use of this. Say in third and fourth, we use first and second. In third one, we use first one because we need this a. We need this a, so we write as this alpha equals to alpha plus minus of alpha. Okay. And this fourth one, we need this alpha as. That's why. In this fifth one, we use the properties of this third properties and the simple properties of this. In the sixth one, we use the properties of the we take this a alpha equals to 0. So there we use some assumption. Suppose we did this a equals not equals to 0, and we did. And for that is if alpha is no, so if we firstly prove that the alpha equals to 0, then this is not equals to 0. When we are trying to prove this a is equals to 0 vector, so we taking at this contradiction method by taking the opposite of that. So I will explain this. This is a summarization of the whole section. So we taking we prove that this alpha equals to alpha is not equals to 0 and a equals to 0. So we take the opposite of that. We take that a is not equals to 0. So then we proceed to we get is alpha equals to 0. But the earlier we take as this alpha is not equals to 0 vector. Same to be by the process of the contradiction we did. The seventh one, we do the basic operation of mathematics, and using the properties of that one, This a minus that's sixth one. In seventh and eighth case, we use the property of the sixth one. And then, thank you for watching me.